short video recapping synaptic transmission. So in front of you should be an image of a neuron, or two neurons essentially. So to break it down into simple terms, we have two parts to it. We've got the pre and the post. So a synapse, in simple terms, is just a small gap between two neurons, which you're witnessing here at the moment, and this gap is called the synaptic cleft, which you can see just by this annotation over here. Now, when nerve impulses are relayed by a neurotransmitter from the axon of a presynaptic neuron, which is the one which is sending, to the dendrite of a postsynaptic neuron, which is what's receiving, this is going to be the key process or the key step within synaptic transmission. The pre sends and the post receives. Now, during this transmission, there's an action potential, and often students get confused or they don't understand what an action potential is. All it means is there's an electrical impulse, and it comes from the presynaptic neuron, and this triggers the vesicles, which are signified by these circles over here, to release neurotransmitters, a chemical message based on the action potential. So in this instance, for the sake of the actual diagram, dopamine is being released. This is the actual transmitter being released. Okay. Now these transmitters diffuse, okay, and they bind to the receptors on the postsynaptic neuron, and that information is essentially received and processed, and that chemical is sort of understood to be what it actually is. And then, depending on the type of chemical it actually is, there's going to be two types of effects. So if a neurotransmitter is excitatory, let's say for example noradrenaline, then the postsynaptic neuron is more likely to fire an impulse. And this is the wording in which you're going to have to be quite familiar with. Is again, is it excitatory or is it inhibitory? But in this instance, noradrenaline is going to be excitatory, and it will lead, or it will cause the postsynaptic neuron to be more likely to fire an impulse. That's something which you have to sort of bear in mind. Now, interestingly enough, dopamine has effects of both being excitatory and inhibitory, but so we have a bit of a clear breakdown between the two. An inhibitory neurotransmitter example could be serotonin, and that leads, and if that is released from the presynaptic neuron, and it binds and it connects to the post synaptic neuron, then it is less likely to fire. Okay, it is less likely to fire an impulse. So if a neurotransmitter is inhibitory, it is less likely to fire an impulse, and if it is excitatory, it is more likely to fire an impulse. And it's this wording which you have to sort of get correct and be comfortable with. But in simple terms, that's what happens with synaptic transmission. So I hope that helps, and that's clarified a bit of confusion with you guys.